Welcome. My name is Jun. I'm a product manager at NeSI. I'll be talking through NeSI's new Research Developer Cloud. It's a programmable cloud infrastructure for building research platforms. And I'll present together with Kahu, who will show you guys one of the example internal project as well, and how we automated the deployment and all that nice stuff. So a bit of a background. NeSI's been providing traditional style HPC for over a decade now, and we have been getting a lot of feedback around needing more diverse capabilities, being able to support services that are more interactive. So a couple of years ago, we started investing into a new infrastructure called Flexible HPC, also known as Flexi HPC. Some of you may have heard of that term before. And the focus today will be a bit of that, but particularly Research Developer Cloud, which we have launched very recently. And that is like a cloud service infrastructure as a service layer that we provide on top of Flexi HPC. So it is basically we're trying to address the needs beyond the traditional queue-based jobs. It's a cloud-native e-research service development and hosting platform. And we are very much focused on collaborating with researchers, not just providing access and leaving you guys to just do anything, but we are much more interested in building things together and being able to contribute back to the wider communities. So with the Research Developer Cloud, we had a recent launch, and the initial set of services and features, we call them essential building blocks. So these are services that allow developers to build and host solutions that can be used by researchers. And it is built on an open source technology called OpenStack. You may have heard of it. It is also being used by Nectar and Catalyst Cloud, one of the public clouds in New Zealand. And the choice of OpenStack means that the solutions that you build will be portable, interoperable, and there will be existing communities out there where the knowledge can be shared around solutions being built. So I'll just quickly describe each of the services. So compute is pretty much being able to launch VMs, and we have multiple flavors. By that, we mean there are certain compute that are more optimized for computational power, and some that are more optimized for high memory usage and things like that. And we have images services that allows you to pick from standard set of operating system images that we have available, as well as creating snapshots of whatever you built and creating new images that other people can use. And we have block storage, and we currently have object storage that is nearly ready to launch as well, so that can be linked with the compute. And we have various networking options. You can set up private networks and various network configurations are supported, and that is built on top of ReENS. So we have a very fast connectivity across research network. And also we have simple identity management, which allows you to create certain application credentials so things can be automated. And all of that, you can access it through the dashboard as well as API. So you can use code to make the deployment processes repeatable and shareable and so on. Here's a screenshot of what our dashboard looks like. So this is basically showing how much total quota there is in this particular project and the usage. And one of the key things that NeSI is trying to focus on that sort of separates us from other cloud providers is we're trying to really promote on DevOps and focused on delivering a great developer experience. And by DevOps, what we mean is that it is sorry, my Zoom window is blocking my notes. It is a set of practices and principles that you can apply to your development cycle to enable collaboration, visibility, and rapid development and deployment, and make it more shareable and better monitored and stuff like that. So as an example, so these are some of the DevOps steps, different stages of DevOps, which is a repeating cycle. And in the code stage, you may use practices and tools like GitHub, GitLab to do source control and develop collaboratively. And then we use internally, we use GitHub Actions to trigger continuous integration and continuous deployment cycle, which does automatic build, test, and release and deploy once the test passes. And we also use tools such as Terraform and Ansible, which Kahu will go into a bit later on, to interact with the Research Developer Cloud through code and do these steps automatically. And once things are deployed, we are also learning and building knowledge around using tools like Kubernetes, which helps us operate, monitor, and scale the services that we developed. And that goes in, that feeds back into the planning and design, and it allows that rapid development cycle. The other key thing is that University of Auckland has recently, not recently anymore, hired a new Chief Information Security Officer, Michael Carrick, who is also part NeSI, and he's guiding us with much of the security practices. And we are also very focused on DevSecOps, which adds security into DevOps. And the key here is we are trying to apply security measures in all steps, and acknowledging that it's not something that you tack on afterwards. So here's a ambiguous diagram, but the gray circle represents the infrastructure, the Research Developer Cloud that we are providing. And we have been working closely with a few different early tenants, and in order to learn and build solutions together that will benefit the research communities. And I'll go into some of the tenant examples together. But the key idea here is that we are really focused on collaborating, building things together that will benefit your immediate research groups, but eventually that can be shared further and benefit the wider communities. So I'll describe a couple of existing tenants, and one is Aotearoa Genomic Data Repository. This is a collaboration with Genomics Aotearoa that we've been doing for over 3-4 years now already. It's a data repository for genome sequencing data for Taonga species. And main challenge here was hosting data onshore and making it findable, making it fair, findable, accessible, interoperable, and reusable. And we wanted to embed kaitia kita nga have built processes for applying and approving and having that consent mechanism built in. And the technologies that we used Gen 3, it is an open source genomic domain data repository solution, and Kubernetes for the management, health, and scaling. And we use things like Google Forms and Zendesk for the approval process. And here's a screenshot of the data repository. And the technology we used for the is called Gen 3, and it is composed of multiple microservices. The details aren't too important here, but the idea is that our research developer cloud enables you to deploy all of these and also set up Kubernetes, which monitors each of the microservices and scale as needed. The other example is ag research. Unfortunately, the previous example and this example both start with AG, which confuses a lot of people, but they are different. Ag research is an institution, and this is a very, very different example where NeSI has big institutional level collaboration to build not just one service, not just a single data repository, but build whole suite of tools and services. And we are still developing together with ag research and supporting them together. And initially, we started off by migrating ag research data and mapping them into correct identities. And some of the early technologies that we used are Keycloak for identity management and Open on Demand, which is a user interface that enables you to access various other services that we built and we will build in the future. And we are also currently using what's called Slurm appliance, which allows you to deploy Slurm and queue-based job submission on top of Research Developer Cloud as well. So all of these collaborations and past the knowledge that we are building together, we are hoping to be able to use that in future engagement as well. So that's one of the key aspirations for us. Here's a screenshot of Open on Demand. So this is just a web-based view that as a researcher, you come in and you will see various buttons that allows you to access to tools such as Jupyter and MATLAB, and you can also gain shell access or submit HPC jobs as well. And here's a simple architecture diagram that mainly shows the different network layers. So you can set up different private networks that can talk to another layer through very specific channels only, and that gives you ability to secure your solution in a very secure manner. And I'll pass on to Kahu.
Cool, thank you for that, John. Just so we're going over everything here, is the training environment was one of the things at NeSI that we decided to test with for us as a learning environment as well, to see what we could do with the Research Developer Cloud. We chose to use Terraform and Ansible because these are particular tool sets that a lot of DevOps practices will be using. Now, Terraform with the change in the license doesn't really affect any of this because you can use OpenTofu, you can use, I believe it's called Plumel, or any other of your code-based solutions to deploy infrastructure should you choose to. So Terraform at this time was used because it's one that I personally know very well and a lot of people do still use. And it was also a way for us to provide possible training outside of NeSI if we get the environment spun up. Now, a couple of the cases that we've used on this side is ML 101, which is just Introduction to Machine Learning and Classification, and ML102, which I believe will be trial testing sometime in the next couple of weeks. And that's about image analysis and deep learning. And we're hoping we can actually get the GPU systems running with that as well. And this is all built on the Research Developer Cloud using, as I said, Terraform, Ansible, and the underlying infrastructure is OpenStack. Now, all of this can be hosted in GitHub. It can be GitLab. It can also be possibly on-prem, as long as you have those connections outside. And we just use GitHub Actions or any of your other CI/CD pipelines that you use to deploy those actual systems down. And for the training environment, we have this rough architecture diagram that I use with my fine degree in arts to draw this for us. And all it is a GitHub repo, Ansible Terraform using GitHub Actions to deploy one node, which on side of that has Open On Demand, Keycloak as the identity service, and then also deploys a small Kubernetes cluster next to it so that we can spawn up X number of Jupyter Hub training environments for the people that want to be a part of that. Now we do have some where are we now? Yes. We'll get there, John. Click faster.
Sorry.
And go to the next one. Yeah, we are. So where are we now? We have a basic environment set up that is reproducible with Ansible and Terraform, and which is based off the ML101 training program. We want to get to the point though where each training environment, when we do deploy it, is deployed on its own right. So you might want to deploy ML101 and ML102, but maybe it's in Auckland, you got ML101, and in Christchurch, you got ML101. So you want to be able to deploy two environments at the same time that are independent of each other so that they can actually run side by side. And also the ability to self-provision these environments, because currently at the moment, it's either a Jun or Kahu question, and we deploy them for people at this point. So we want to actually automate a lot more of that process so that there's even less need for us and it's more given back so that anyone can run these programs. Now, from a couple of our experiences, we do have the GitHub repos, and I prepared this link in my clipboard earlier, so it's easier to see it and read it. This is a very, very basic Terraform example where we use the actual Research Developer Cloud. All it does is generates one VM, attaches it to a network, gives it a floating IP address, and then SSH onto it to run an Ansible ping, and then shut it down and destroy it afterwards, all in the space of about 2 minutes. So it's there, it's reproducible, and you can do it over again, and it's run through GitHub pipelines, so it's easy to use and things like that. Now, other experiences, when we continued on from that, we started moving into more of the training environment itself. And there we go, another link for everyone to those who enjoy light reading. This one is a bit more light than the previous one. And this one is taking what we learned from that last example and building it further again to give us what the training environment is today. Now, this is full on Ansible roles and Terraform. Terraform provisions the infrastructure, orchestrates the infrastructure, and then we use Ansible to do a lot of the configuration of that infrastructure. And this includes the roles all the way from Open On Demand right down to Keycloak. Included in this training environment as well is a Kubernetes cluster should you need it. It has actually been designed so that you can have a Kubernetes cluster or not have the Kubernetes cluster. And we went a few routes with this. There's the open source solutions like KubeSpray and stuff like that. But we decided we might try and go with a cluster API. And that basically means that you can define your entire cluster as just a simple template and then just submit it. And then you'll always get the same cluster at the end, no matter how many times you've done this. And I think Chris and myself have destroyed this entire environment probably 10 plus times, and it always returns to the same point, which is the whole point of the whole DevOps lifecycle. I should be able to reproduce the same thing that I've had every time over and over again. So a lot of examples and training that we've learned from ourselves when it comes to these things. I believe that's the end of me talking, John. I believe that goes back to you. Yeah, nailed it.
Brilliant. Thank you. Yeah, so next, Kyle, so that showed one of the examples of what we are calling blueprints, so repeatable patterns that can be configured for to solve some of the research problems or building solutions for researchers. We want to be able to build more blueprints and shareable knowledge together. And we are inviting you to apply for early access. especially if you are developing some complex solutions that support custom workflows and a range of user experience, and seeking locally owned and sovereign cloud computing platform to build and develop tools that can support research data collaborations. And if you are interested in partnering with NeSI to apply DevOps approaches and best practices to your research activities, and eventually benefit communities beyond your own. And we are really keen to learn about your use cases, what you wish you could build, where the gaps might be, DevOps skills and expertise, and what you'd like us to focus on next to help you. And I think Jana has shared that link on the chat earlier, so you can read more about the Research Developer Cloud on that link, and you can feel free to reach out to us at support@cloud.nesi.org.nz. And these are various NeSI people who have worked on the Research Developer Cloud and Flexi HPC, along with our early tenants, partners, and providers. Thank you.